Today I'm going to talk to you about some interview questions for FEA stress analysis along with their answers. If you like this video and want to watch similar content, do like and subscribe to my YouTube channel. First question: what is shape function? Shape function is a mathematical function that expresses the displacements inside an element as a function of the displacements at the nodes. So, after solving the equation, after the solution process, we get displacements at the nodes. How will we know displacements inside the element? For that, we have this shape function. For that, we need this shape function. So, in most commercial FEA software, they use only linear or quadratic functions. Question number 2. What is the expression for stiffness matrix? The expression for stiffness matrix is K matrix equals integral B matrix transpose into D matrix into B matrix dot dV, where B is the strain displacement matrix, D is the stress strain matrix, V is the volume of the element, and K is the stiffness matrix. Question number 3. Illustrate boundary conditions for a simply supported beam. This is one of the most popular interview questions that I have seen in my personal experience. So if you look at the screen, you will see that on the left we have one boundary condition which is ticked correct, and on the right we have a boundary condition that is ticked wrong. So this differentiation is very important, and it is looked for by the interviewer. In a linear analysis, both these boundary conditions will give the same result, but if you switch on the geometric nonlinearity, it will be different. The usual intention of the analysis is what is given on the left, so we must be careful in telling that. Question number 4. What are the various mesh quality parameters to be considered for stress analysis? This is also a popular interview question. So the various mesh quality parameters that are to be considered for stress analysis using solid elements are element size, aspect ratio, Jacobian, skew, warpage, maximum angle, minimum angle, and if you are using tetrahedral elements, you also have to consider tet collapse. Question number 5. What is solution convergence? This is a very important concept that I have seen that many engineers working in the FEA field sometimes don't know. So just because you come up with a random mesh and you solve the analysis does not mean that the solution will be correct. You have to decide the proper mesh size. For that, this solution convergence concept is central. Solution convergence is the process of getting a result with an acceptably small error by varying the mesh size. So when we progressively refine the mesh, the solution changes. So how do we decide which solution is correct? So you go on refining the mesh till the solution does not change much. So at that stage we say that mesh independence has been achieved, and this process of varying the mesh size uh, to determine the correct mesh size by seeing the solution, that is called solution convergence or mesh convergence. Please note, this is different from nonlinear convergence.